Welcome to my tutoring session in chemistry. The current video is part 3 of the 4-part series in thin layer chromatography. In this video, I'll explain how to monitor the progress of a chemical reaction by employing TLC technique. Let me consider the synthesis of aspirin from salicylic acid as a representative example to explain how to monitor the progress of a chemical reaction. Aspirin is synthesized from salicylic acid by esterification reaction. When you treat salicylic acid with acetic anhydride and catalytic amounts of concentrated sulfuric acid and reflex the reaction mixture for a period of 30 minutes, the orthohydroxy group of salicylic acid undergoes esterification, resulting in the formation of the desired product, that is aspirin. Take a round bottom flask and transfer 0.15 mole of salicylic acid, 0.5 mole of acetic anhydride and 5 drops of concentrated sulfuric acid as a catalyst for this particular esterification reaction. Fit a reflex condenser to the round bottom flask containing the reaction mixture and reflex for a period of 30 minutes. After the completion of the reaction time, you have to work up the chemical reaction. Now the workup procedure is not a purification procedure. In fact, it is a procedure that is meant for the isolation of the product from the reaction mixture. And this is how we are supposed to carry out the workup procedure for the isolation of aspirin from the reaction mixture. First, cool the reaction mixture after the refluxing period. Take a capillary tube and immerse the capillary tube inside the reaction mixture, and by capillary action, aliquots of the reaction mixture is drawn into the capillary. Take a glass vial containing ice cold water and transfer the reaction mixture containing the capillary to the vial containing ice cold water. You will find precipitation, which is possibly our desired product, and extract this precipitation using ethyl acetate. And during extraction, screw cap the vial and give a brisk shaking, whereby the desired product or the precipitated product, it gets transferred into the ethyl acetate layer. Take another fresh capillary and touch the tip of the capillary to the ethyl acetate layer, whereby aliquots of the ethyl acetate layer is transferred into the capillary by capillary action. Take a TLC plate, draw a baseline using pencil, mark reference spots on the baseline and label these spots where you are supposed to apply the aspirin reaction mixture as well as the starting material, that is salicylic acid. Now labeling of the marked spots is very much essential, as you should know where actually you are applied or what is the component that you are applied on the baseline. Here A stands for aspirin, R for reaction mixture, S for the starting material, that is salicylic acid. Now take the ethyl acetate layer using the capillary and touch the tip of the capillary containing ethyl acetate layer for a very brief period and withdraw the capillary immediately. Similarly, you apply the salicylic acid at the desired spotting marked as S. Now salicylic acid is a solid. Prepare the solution of salicylic acid by dissolving in dichloromethane, and likewise prepare the aspirin solution in dichloromethane solution. Separate glass vials are to be used for the preparation of these solutions. Use a separate capillary for transferring the standard aspirin solution and another capillary for transferring the starting material, that is salicylic acid. A stands for aspirin, which is the authentic sample or the standard sample. R stands for reaction mixture, while S stands for the starting material, that is salicylic acid. Now, how do you know when to stop the reaction mixture? Now, this is a very well established procedure, that is synthesis of aspirin from salicylic acid. So we know the reaction conditions as well as the reaction time. But what about unknown reaction? What if this reaction was unknown? And how do you judge the reaction time or the reaction completion time? And that is where the TLC technique comes handy. So you have to check the TLC profile for brief periods. Now let's try and check the TLC profile of this reaction mixture after 5 minutes. Now stationary phase is polar silica gel, mobile phase is hexane ethyl acetate mixture. When you run the TLC after 5 minutes, you will find that the reaction mixture still contains salicylic acid, unreacted salicylic acid. So when you compare the reaction mixture spot to that of the salicylic acid spot, you'll find that they have traveled the same distance. So this indicates that the reaction is not started or initiated. So there is no reaction, as salicylic acid still remains in the reaction mixture. Now let's check the TLC profile after a period of 20 minutes. And now we see that a new spot has appeared in the TLC plate. And this may possibly be our desired product, aspirin. Now in the reaction mixture, as per the TLC profile checked after 20 minutes, we find two spots. One spot for the starting material salicylic acid and another possible spot which could be of that of aspirin. So still there is salicylic acid present in the reaction mixture, unreacted salicylic acid. So we can conclude that it is an incomplete reaction. So samples are applied on the baseline and stop the development, TLC development, when the mobile phase has traveled the required distance over the TLC plate. Now the distance traveled by the standard aspirin is represented by the blue circle. Distance traveled by the standard salicylic acid is represented by purple circle. So it is an incomplete reaction. Now let's try and check the TLC profile after the 30 minutes recommended reaction period for preparation of salicylic acid, aspirin from salicylic acid. Now this is the TLC profile after 30 minutes, and we find that in the reaction mixture, you find only one spot, And the distance traveled by this spot in the reaction mixture correlates to that of the distance traveled by aspirin. And we don't find any spot for the starting material or that of salicylic acid. So you can conclude that the reaction is complete. So now you can work up the entire contents of the round bottom flask. The entire reaction mixture contains the round bottom flask. You take a beaker containing around 100 ml of ice cold water, and you can pour the cool reaction mixture into it and stir the reaction mixture using glass straw and filter the product. And further purification can be done by crystallization process. And the RF value can be calculated for the respective spots by using the formula distance traveled by the compound from the baseline divided by distance traveled by the solvent. So we have successfully synthesized the aspirin from salicylic acid by esterification reaction. And we have monitored the completion of the reaction by employing TLC technique, that is thin layer chromatographic technique. Now, in addition to employing the TLC technique for monitoring the progress of a chemical reaction, there are additional applications like TLC technique can also be used for identification of the synthesized compound by its RF value. What do you mean by RF value? RF stands for retardation factor or retention factor. So we have run the TLC for a pure aspirin sample that we have synthesized after purification, and we have found the RF value to be 0.5. So how to calculate the RF value? To calculate the RF value, we need a baseline detail, the distance traveled by the desired compound, here in this case it is aspirin, and the distance traveled by the solvent front. Let's say X is the distance traveled by the compound aspirin from the baseline, and always consider the center of the spot when you are trying to measure the distance traveled by the molecule from the baseline. And Y is the distance traveled by the mobile phase, that is solvent front, from the baseline. So you can calculate the RF value by dividing the distance traveled by the compound from the baseline by the distance traveled by solvent from the baseline. Now usually the RF value ranges from 0 to 1, and an ideal RF value could be somewhere around 0.3 to 0.5 at an average. So fix the mobile phase so that you end up with the RF value somewhere around 0.3 to 0.5, which will be ideal. Now RF value is used for identification purpose as it is constant value for a given combination of stationary and mobile phase. But RF value can vary the moment you change the mobile phase. Say for example, you're using 1:1 ratio. Let's say we are using 1:9 ratio of hexane ethyl acetate combination. Now when you change the ratio to 1:1, then the distance traveled by the aspirin will vary. So the RF value is constant or a specific value and is used for identification of the substance, and this value, it may vary, and it is a constant value depending on a given combination of stationary phase and mobile phase. So here, how do you calculate the RF value for aspirin? Divide X by Y. Secondly, TLC technique, it gives a good indication of the purity of the synthesized compound. So purity of the synthesized compound can also be assessed by TLC technique. Now in this particular chemical reaction involving synthesis of aspirin from salicylic acid, we have placed the TLC plate in the saturated TLC chamber, and the mobile phase, it travels through the stationary phase, or it moves through the stationary phase by capillary action, and the components get separated depending on its relative affinity towards the stationary phase. And after the solvent development is complete, when the solvent has reached the reference line, stop the development, remove the plate, dry the plate, and when you check the plate under UV light, the spots appear, and this is the TLC profile after 30 minutes. So the reaction is complete. Now when we check the TLC profile of this particular reaction involving synthesis of aspirin from salicylic acid, we found that there is a impurity spot at the lower end of the TLC plate, that is slightly above the baseline. So this is the standard sample spot for aspirin, and this is the spot for the aspirin that we have synthesized in the laboratory. And the small spot, what you see slightly above the baseline, is the impurity spot for salicylic acid, which indicates that the reaction is incomplete. So TLC technique can also be employed to assess the purity of the compound. Additionally, TLC technique is also used to determine the solvent system. When you're trying to purify the compound by employing column chromatography, TLC technique can be used to fix the solvent system, and also to monitor the column fractions during the separation, employing column chromatography. Now to summarize, TLC technique is a quick and easiest method to monitor the chemical reaction. It is a universal method employed to monitor the chemical reaction. And a chemical reaction should always be monitored by TLC technique, even though it is a well established reaction or it is a procedure which is already been mentioned in the literature. So despite the fact that the reaction is well established and well reported in the literature, it is better, or it is always recommended, to monitor a chemical reaction by TLC technique. Thank you so much for watching my video. I hope you enjoyed it, and I'll meet you in my next interesting tutoring session.